Let's create a program. We even call it, you could say, a modular program. In this program, it will be a live script. And this live script will call our function area circ that calculated the area and the circumference of a circle. And then we'll go ahead and create a live function. And the live function in this case will not return a value, however, it will print. So the function will print an output, but it doesn't return any calculated values. So let's start with a new live script from the Home tab. And let's see. Okay, so I created a live script and I saved it as example program. And this program will call area circ function, and then we'll create another live function to print the values. So I'm going to create a variable radius values, and in this case I'll just make it a scalar too, right? My input radius. So to call our function, I know I'm going to get the area and circumference, so I create two variables, and my function call is area circ. And so I'm using the autocomplete. I typed in A, and here's a list of my functions and the MATLAB functions, area circ. I could mouse click on it or hit enter, and a pop-up tells me I need a value for the variable rad. And so I type in RAD. So now I'm just going to go ahead and hit tab for autocomplete, and you see what's highlighted. My radius values that I described in my input. And it minimizes spelling errors by using the autocomplete. And now I want to terminate with a semicolon so nothing's displayed to the output. I'm going to go ahead and save. And now I want to create a function that will print these values. So I go to New tab in my live editor, and now what am I going to select? I'm going to select the live function option. And now you see our template is a little bit different, right? The brief summary of the functions up on top, and a detailed explanation of the function is underneath that. And now here is my code for the function. So I'll name the function print. print circle values. So my default input variables is x and y. So I'm going to change x to A for area. And I'm going to change y to C variable for circumference. And like I stated earlier, I'm not going to return any values, so I could delete my output argument z, and I could remove my equal sign. So now this is not an assignment statement. My function header is not an assignment statement. It receives input arguments a and c. So what are we going to do with that? I want to print So I'm going to use the fprintf function. The area is, now I'm going to use my format symbol 3.2f. And so this filled width of 3, 2 decimal places of precision. Backslash for new line. And now a comma. A for area, C for circumference. So just a quick summary of what's happening here. When I call this function, the value for A is going to be passed to the fprintf statement, and it's showing up here for A, and same with C. Those are my input arguments, and then I can print A and C, and it's going to print A for the area, filled width of 3, F is floating, 2 decimal points, circumference, and so the first one is A, and the second one is C. So now let's save as, because I want to put this in my MATLAB functions. The value, the name of the function is print circle values is updated. It's MLX live function. Now I can hit save, right? What is my brief summary? Print area and detailed explanation, input area and circumference. No output value is returned, and I hit save. If we go back to our program now, I could call the function. So again, I'm using the autocomplete features, right? Because my function name is print circle values. So PR and a list of functions that start with PR show up. And so I could see print circle values. It even has a live script icon to it, a live function icon rather. I can double click on it, and now my input values are area 1 using autocomplete tab, circumference 1. I could save this, and now let's run our program. So my live program is going to call area circ function. It's going to calculate the area and circumference for a radius of 2, and then it's going to call, well, first the area circumference, area circ, is going to return the values that was calculated by the function, area 1 and circumference 1. Now I'm going to call the print circle values function, and I'm passing in the values from area 1 and circumference, and it should print it out to the screen. Now notice in this case it doesn't matter that one's a live function and one is just a normal function. They're going to operate the same. So let's run and see what happens. Actually, so I'm going to put the inline results. So we see after we called the function, our formatted printf statement says the area is 12.57 and the circumference is 12.57. Do I have an error? I mean, it seems kind of funny that the radius of 2 is giving me the same area for circumference. So let's debug this and see what happens. So I'm going to go back to my function and area circ function. And put a breakpoint. Go back to my program. Run my program, and see, notice what happens. I ran my live script program. It called area circ function, and we stepped into the function. And if I stand on rad, I see rad is 2. And if I step, my area is calculated 12.56. And pi times 4, because 2 squared is 4, is 12.56. And if I do one more step, I see the circumference is 12.5664 also. Which indeed it is correct, right? Because the radius is 2. 2 times 2 is 4 times pi. And the area calculation, radius is 2, squared is 4 times pi. So yes, indeed, area and circumference are the same value for a radius of 2. I'll quit my debugging. I'll disable my breakpoint. Go back to my program. And we'll try a new value, 4.25. We'll run the program. And we call the functions, and we have the areas 56.75 and our circumference is 26.7. So in this case we have a function that does not return any calculated values, and that is, it just does the printing, print circ values. So hopefully you could see the value of functions, as if we do this repeatedly, you're calculating the area of a circle over and over again. You just simply call that function every time you need to do it, and you could pass in any values for radius values, and saving your code, and you could put these into a modular program, if you will, a simple modular program, as opposed to writing out a complete program with all the lines of code in there and save them out individually. So that's a brief description of a modular program. It's a live script calling a MATLAB function area circle that returns two values. Then it calls a live function print circle values that does not return anything in the function call. It just prints the statement. So another function in MATLAB is a special case. It's called a local function. And it's termed a local function because it's saved or included in a program. And there's a special requirement for local functions, and that requirement is if you save a function in your program, it has to be at the very end of the program. You can have more than one local function. You can have two functions in your program as long as the last function is at the very end of the program. And this is a case that's very important that you include the end statement. If you refer to the help pages in MATLAB for creating user-defined functions, you'll see that they mention the end function is optional. And it's only an option if it's not a local function. When you have a local function saved in a program, you must use the end function. So let's create a local function included in our example program. So in this case, we can't open up a template, but we could just follow the same template where we use the function, keyword, the output variable. Let's create an assignment statement, the function name, so I'm going to call my function name the cube value. And my input variable is going to be y. And if you notice, I have not a lot, but I have two red symbols up here saying it's an error. And my function has a little wiggly line under it. But look what happens. If I go ahead and do a return after the function header, and automatically appears. MATLAB automatically added a section break. So now my function's at the end of the program. The last line is 12, and 12 is my end statement. So I'll have summary. Summary is cube value. X is cube value of y. Y is scalar or array. So x is my return value. I'm going to create an expression, y. So if it's going to be an array, I have to use element wise dot caret cubed 3 for cubed. And we're done. So what's going to happen if I call the cube value, y is the input value. It's on my expression on the right-hand side of my assignment statement. Y will be cubed, assigned the values to the variable x, and it matches my return variable x for my output arguments. Argument, I should say. This only has one output argument, right? So I could say the cube is equal to the cube value. Again, using autocomplete, I'm just going to click on it, and I'm going to put a value of 3 here. If I run the program, the result is 27. So note, my function is only local to this program. It's not saved on a computer anywhere. It's not saved in a current directory. I could show you that. The only thing in my current folder is example program. And let's go back to my desktop again just to show the workspace. The only thing in my workspace is area 1, circumference 1, radius values, and the cube. X and Y do not show up in my workspace. Because remember, they're in the function workspace. And to demonstrate that, I could put a breakpoint on line 14. If I run my program again, now line number 9 is highlighted when I make the function call to the cube value. 14 now is red circle around it, and we're highlighted on 3. If I stand on y, y is equal to 3. X does not have a value because it's not computed yet. And if I go back to my current workspace, I only have y in my workspace. I'm in a debug mode, so my cursor is K. But notice all of the normal workspace variables, area 1, circumference 1, they're not here, right? Because it's telling me I'm in workspace, the cube value, I'm inside the function. I'm in the function workspace since I'm in the debug mode. And so if I do a step under the run, now I go down to line 16, it's highlighted. X now has a value. If I stand on it, it's 27. And then jump back to my desktop, both X and Y. Columns are very wide here, so I'll bring them over. And I could clearly see inside my function workspace, Y has a value of 3, X has a value of 27. If I jump back into my program, I can hit continue, and we're back up to the normal condition in our program completed. We're not in debug mode because the stop is no longer enabled. I could disable the breakpoint line 14 because if I forget and run it again, we'll stop there. So notice also, I told you that the local function had to be the last line of code in the program. If I tempt it and I say I want to put in a assignment statement, x is equal to 0, immediately I get a red error. If I stand on it, it's unambiguous. It's telling me explicitly the function definitions in the script must appear at the end of the file. Move statements to before the function definition. So if I really want to have x assignment statement is equal to 0, I need to put it before line number 10. I don't need this. I just wanted to show you that if you don't have the function at the end of your program, you'll clearly get an error. In this case, the error is explicit. It's not really difficult to understand. It's not cryptic. It tells you that the function must be at the end. And as promised, I said, what if you wanted to have more than one local function? Well, let's create one and see. So function, in this case, I'm going to use the exact same variables the sum and A and B. So sum two numbers. X as my output variable is going to be A plus B. Now this really is an exciting function here, but I just want to demonstrate that we could have multiple local functions, again, as long as the function is the last line of the program. So we do have a function here, and it's the last line, 23. I'm going to call this function. So I just typed in uppercase T, and again, my autocomplete shows up, right? And I'm going to use my down arrow, not the mouse. And I see the sum. That's the function that I want to call. I'm hitting enter. And I need to put two input arguments, A and B. And I'll do it 2 and 4. Run my program. In this case, I'm going to change this to 2 just to show that both functions work. Actually, before I run it, I want to go ahead and I don't know if you noticed in your coding or not. I'm going to delete these lines here, right? If you right-click your mouse button in the field, go down to the bottom, clear all output. So now we just have our code left. So now I'm going to go ahead and run. So now the cube is 8. And believe it or not, 2 plus 4 is equal to 6. So this simple modular program was a live script, and it calls two functions. I'm going to clear the output again. Clear all output. So what does it do? Just to summarize, it calls area circ, which is a function stored in my function folder. and it is not a live function. And then I have a print circle values function. It was a live function saved out onto my functions folder. And the print circle values does not return any calculated values. It just prints to the screen. And then I added two local functions. And just keep in mind the importance of the word local is it's only local to this function. I cannot call the cube value or the sum from any other program because it's only saved inside my example program. Hence, it's local to this program. In this case, for you, that's really convenient for using the virtual machine. But eventually, you may be in the work environment where you won't have a virtual machine and you'll have your function directory, and you'll have to set your path to that function directory, and then you'll be able to use all of your functions for whatever current folder location you're working under, because it's in the search path. So that's it for functions, live functions, local functions for this episode. Thank you.